Okay, this is a Higgs film. It's HERA 2 Lepton Proton Beam Spin Collider Accelerator Higgs Boson Mass Particle Research. So this is the keywords HERA from this data is from the previous video. HERA 1 and HERA goes up to 6. So there's 6 videos about HERA itself. So the measurements of isolated photons accompanied by jets and deep inelastic EP scattering, ZEUS Collaboration. So I googled HERA luminosity value at www.zeus.desy.de, and September 14th, 2012 is when I worked on the data. Today is October the 4th, 2012. So the keywords is proton beam HERA, and there's a picture of it. So a small segment of the HERA tunnel. The proton beam is traveling in the large vacuum tube in the middle to the right. The electron beam is below that. So quotes from Wiki. That thing's huge. Quotes from Wiki. HERA, the Hadron Electron Rangelange or Hadron Electron Ring Accelerator was a particle accelerator at DESY in Hamburg. It began operating in 1992. At HERA, electrons or positrons were collided with protons at a center of mass energy of 318 GeV. It was the only lepton proton collider in the world while operating. Also, it was on the energy frontier in certain regions of the kinematic range. HERA was closed down on 30th of June 2007. Leptons and protons were stored in 2 independent storage rings on top of each other inside this tunnel. There are 4 interaction regions which were used by the experiments H1, ZEUS, Hermes, and HERA B. All these experiments were particle detectors. Leptons, electrons, or positrons were pre-accelerated to 450 MeV in the linear accelerator LINAC 2. This storage ring was equipped with warm, non-superconducting magnets, keeping the leptons on their circular track by a magnetic field of 0.17 Tesla. Protons were obtained from originally negatively charged hydrogen ions and pre-accelerated to 50 MeV in a linear accelerator. They were then injected into the proton synchrotron DESY-3 and accelerated further to 7 GeV. I'm going to pause this for a second. This is the second part of the HERA 2 Lepton Proton Beam Spin Collider Accelerator Higgs Boson Mass Particle Research. I had to pause it because I got a phone call. Okay, so I was talking about reading about the HERA and how it worked, and it says the protons are obtained from originally negatively charged hydrogen ions and pre-accelerated to 50 MeV in a linear accelerator. They were injected into the proton synchrotron DESY-3 and accelerated further to 7 GeV. Then they were transferred to Petra, where they were accelerated to 40 GeV. Finally, they were injected into their storage ring in the HERA tunnel and reached their final energy of 920 GeV. The proton storage ring used superconducting magnets to keep the protons on track. The lepton beam in HERA became naturally transversely polarized through the Sokolov-Chernov effect. The characteristic build uptime expected for the HERA accelerator was approximately 40 minutes. Spin rotators on either side of the experiments changed the transverse polarization of the beam into longitudinal polarization. It's really interesting to see how much work they go into to test these signals. I had no idea how much they had to do. It's crazy. The positron beam polarization was measuring using 2 independent polarimeters, the transverse polarimeter TPOL and the longitudinal polarimeter LPOL. Both devices exploit the spin-dependent cross-section for Compton scattering of circularly polarized photons off positrons to measure the beam polarization. The transverse polarimeter was upgraded in 2001 to provide a fast measurement for every positron bunch, and positron-sensitive silicon strip and scintillating fiber detectors were added to investigate systematic effects. On June 30th, 2007, 11:23 p.m., HERA was shut down, and dismantling of the 4 experiments started. HERA's main pre-accelerator Petra was converted into a synchrotron radiation source. operating under the name Petra 3 since August 2010. September 22nd, my thoughts. Use the collider designs from HERA with the NONET formula idea for the Higgs Boson Mass Particle. Warm electromagnetic forces with the 0.1 Tesla keep the protons stabilized in the middle without accelerating them first. The Lepton Beam add the WOW formula to change what particles are in it. Neutrinos, cooled liquid argon gases, and split leptons and fermions. You want your beam to be a pulse, not a longitudinal polarization. Petra 3 is a synchrotron radiation source used in the beam. Google to see what it is. So this is a picture of it. Shows a magnet with a synchrotron light. Synchrotron radiation from a bending magnet. The electromagnetic radiation emitted when charged particles are accelerated radially. AB is called synchrotron radiation. It is produced in synchrotrons using bending magnets, undulators, and/or wigglers. It is similar to cyclotron radiation, except that synchrotron radiation is generated by the acceleration of ultra-relativistic charged particles through magnetic fields. Synchrotron radiation may be achieved artificially in synchrotrons or storage rings, or naturally by fast electrons moving through magnetic fields. The radiation produced in this way has a characteristic polarization, and the frequencies generated can range over the entire electromagnetic spectrum. Okay, thank you for watching. I'm going to go on to the next Higgs video.